All right. Hi, everybody. I've there is another video that you can watch that is sort of the Lab 4 experience with NetLogo, which kind of goes over things that are specific to the lab. But I usually have also a lecture component just talking about NetLogo sort of modeling and implementation fundamentals. And this is usually embedded within lecture C2, which is in kind of an introduction to system dynamics modeling and agent-based modeling and the motivations behind those. I'm going to leave a lot of those motivation and background back for lecture C2, but I wanted to split out the NetLogo specific stuff, specifically modeling and implementation, for those who want to have more direct access to this material and those that are maybe working on the lab and want sort of again, more direct access, more convenient access for that. So NetLogo, just jumping straight into it, this is a Java-based program, so it's a program which should work on Mac, Linux, and Windows. You can download it, but as I'll mention in a second, it's also something that you can at least run models from the web. It's an interpreted language, so it's not like you write code and then compile it and run it. So it's going to be more like various like Python and things like that are interpreted languages that you write the code and you can sort of immediately run them. But it is more than just a language. It's sort of embedded within an interactive environment that allows you to interact with the system, to modify parameters kind of in real time, to get data out, and so on and so forth. And so it's really meant to be more than just a programming language. It's really meant to be a language built around simulation and generating data. And it's a totally free program. So this is a program that came out of a university research effort that I think was NSF funded, and so this isn't something that you'll ever have to pay for. So you can actually go to the URL at the bottom of the page here and take a look. And so if you did that, you could also find access to NetLogo Web, which which is interesting because not only can you run models that you've built on a inside a web browser, but you can even run them on a tablet. And so you might have a really interesting result and you want to show more than data. You want somebody to be able to play with the model, but you can send them your model either as a web page that could be attached to an email, or you can actually just send them a URL, and then right on a tablet you can then have them demo it, or you could demo it even if you didn't actually download the software and install it. All right, so here is an example of some advanced things you can do with NetLogo. So this is a sample from a colleague here at Arizona State. So this is a combination of NetLogo, an agent-based modeling platform, and geographic information systems, GIS, ABM GIS. And so you can see that you can actually bring in, so this is this is Florida here, so the panhandle of Florida. You can bring in very fine resolution data from a GIS system, and topographical features, etc. And then with that, you can make your simulation actually be linked to certain geographic properties that might be realistic. And so this was an example that they did where they actually were interested in, so all the blue dots and red dots and cyan dots and all of those are all clusters of people that they're interested in understanding how those people respond to different sources of information when there is an impeding, potentially dangerous event like a hurricane. So they're simulating a hurricane coming in, and then they can then say, well, what happens if people receive information about this hurricane far ahead of time, and there's not a lot of certainty in whether that hurricane is going to hit at a particular spot. But as it gets closer and they get more certainty, then those messages become more reliable. But if you flood people with those messages too soon, then maybe they stop listening to the messages later. So if you ultimately want to get as many people evacuated out of the right areas, then a simulation can sort of tell you how to adjust your protocols, given that you know that people will start not trusting the data if they find that it seems too reactionary or too unreliable. So that's something that they could play with there. Other things that you can do with this sort of GIS, if I go into NetLogo on my own, and so we'll see this in a second, examples of this, I can go into the models library, and under the models library, these are a bunch of pre-built models that you can play with or build off of. I think there's might be an earth science, Grand Canyon, so that's something that as sort of locally interesting here. And just on the subject of things kind of related to ABM GIS, this is a sim where when I click setup, it will bring in real topographical data, like you see here. And if I hit go, it simulates rain on the surface of the Earth. And as these little droplets or packets of rain end up hitting the surface of the Earth, then they respond to the gravitational potential, and they can end up sort of flowing downhill. And so, with a simulation like this, then you can end up sort of watching the way in which water flows down these surfaces and accumulates at certain spots. So that is an example of where you can have these agents interact with real data from the environment. So I can test hypotheticals, like I can increase my rain rate, and so it might rain a lot more, so I've got a lot more water flowing per time instance, and so this will get a lot bluer, and we can kind of see what happens there. So example of how you can combine these things with real data, or they can be totally sort of fantastical. So as an example of that, I can also open up this model here. So this is if I go into NetLogo's models library, and in this case, I'll look under biology, and this is the ants simulation. And so this is a very sort of stereotyped representation of ants that lay pheromone trails to lead themselves to food. And so these ants are at some central nest, and there's food, and the abstract food in this location or this location or this location. So this looks very different than water flowing down the Grand Canyon. This is totally kind of cartoony. But the basic idea is try to understand, if you were to lay down pheromones to attract your nestmates, then could that possibly lead to some, in a hypothetical mechanism that would allow you to effectively search the space and bring back food in a coordinated manner. So if I hit setup and go, I can watch what happens. The ants are searching. A couple ants found the nearby one. They end up laying down a pheromone trail, which ends up getting depicted as a change in color of the world. They manage to find and exploit the closest one first, and then they end managing to find and exploit the next closest one, and then eventually this one they'll all coalesce on and then exploit that until all of the food has been foraged and brought back. So I'll stop that a little early here. So you can see this is, like I said, a very cartoony example, but it at least demonstrates a principle, and that's why it's still potentially a useful simulation. So let's look at the interface here. So if I'm looking at this ants model, I see that right on the main interface, where this little interface tab is, I've got sliders, input buttons, switches, menus, monitors, plots, commands, and comments. And so those are all the things that I can sort of see. So I can switch back to this NetLogo model here, and you can see these. This is a slightly different implementation of the ants model. So here they have a couple other things that they've included, but in this newer version they've taken out. And so actually, I'm sorry, this ants model back here was actually built as a modeling class, someone extending the ants model with these other features, and this is kind of the basic one. So you can see how you can take a basic one right out of the NetLogo software and then add your own flair to it, and as a way to get to know the software package. But the basic idea here is I usually change my input parameters, like the population size of the ants, with things like sliders. So I can generate a slider. So if I were to right click on this background, I can end up adding a slider to the interface, a switch, a chooser, all these different things. So with that slider, I can right click on it, I can go to edit, and I can actually say, all right, this slider starts at 0, it ends at 200, every tick of the slider is about 1.0, the current value is 53, here's its name, and if I wanted to add units for flare, I could put that in here. I could even switch to a vertical slider. So can configure these things, and these things show up as variables in the code that then you can use later. Other things like these buttons, if I hit setup and it reset the world, because if I were to right click on the setup button, let's see that whenever I click it, it ends up running the setup command, and the setup command resets the world. So we've got these different things that we can drag on here and configure, but there's no wiring of these things together like you might see in Arena. Arena, you'll drag on elements and then you'll connect them together. So the actual programming doesn't go on this interface page the way it does in Arena. Like in Arena, most of the logic comes from wiring elements together graphically, whereas the actual programming goes on here by typing things out kind of the old-fashioned way in this little procedures or code tab, depending on your version of NetLogo. So let's move toward that. So like I said, with a blank interface, I can end up adding button slider switches to this. I always, by default, will start with this sort of main plot here, which if I right-click on that and go to settings, I can then change sort of the size of this world. And so I can say, do I want this world to be, what do I want this bottom corner to be? What are the coordinates of this bottom corner or this top corner? Do I want the world to wrap around? In other words, if agents run off one edge, do I want them to come back on the other edge, or do they just hit a wall? Is it impossible for them to walk off this world? Likewise, the same with the top. So these are just examples of what all those things look like: buttons, sliders, monitors, text comments, outputs, etc. So there's also inputs where you can actually type in numbers. So there's all sorts of different ways that while the simulation is running or just before it's running, you can interface with it. Then the other nice thing that we work on before we get to code is if I go to NetLogo, under the tools here, I have this thing called behavior space. And under behavior space, this is where we do, so industrial engineers will at some point in their career probably take a design of experiments, a DOE or a DOX course. And so, this is usually focused at running experiments in the real world. Well, these simulations are just as stochastic as simulations in the real world. And so we have behavior space that automates running these experiments for us so that we don't have to go and play with the interface manually and change it every time we want to explore something. So if I hit new here, I'm brought up with a new experiment and it's automatically populated with the names of the sliders that are on my interface and the current values of those sliders, 10, 53, and 50, 10, 53, and 50. But I could go in and I say, well, I actually want this experiment to try every value of the evaporation rates at the levels 10, 20, and 30, and every population at 50, 75, and 100. And maybe I'm okay with one diffusion rate for this experiment. And so it will then go in and do the 3 times 3 times 1, so 9 different experiments. So it does the full factorial experimental design here, all 9 treatments, and I can say how many replications do I want. So I want 10 replications of each of the 9 treatments. And so if I were to save that experiment, it says 90 runs. Well, the way it got 90 is it just did 3 times 3 times 1 times 10. That's 90. So going back into this sort of pre-cooked example in the slides here, here they want to study this, this model at these 3 different failure rates with preferential attachments set to either true or false. So that's 3 times 2. That gives them 6 different treatments, and then they can then run each one of those experiments 10 times, and that will end up giving them data. So this is an automated way of running experiments so that you don't have to manually play with it, and the output will end up being a spreadsheet that you can analyze in a piece of software like Excel or R or whatever.